Hello everybody, welcome to Breadboard channel. Today I'll be talking about switches.
Switch off, switch on, switch off, switch on, switch off.
Not that kind of switches. We could probably do something with that switch, but it would be very impractical on a pedal. What I'm going to talk about are stomp switches or pedal switches. Firstly, I'll do some introduction about switches, just some basics, and then I'll talk about what true bypass means, and finally how to wire up your breadboard and pedal using these switches. And I'll be then talking in the end about alternative ways to wire up your true bypass with something like this, more common switch for pedals. Anyway, as always, I'll probably over-explain, so feel free to skip to the part you're interested in. By the way, all schematic and diagrams can be found on my website, and link is going to be in the description. Also, there won't be much playing guitar in this one. You'll be warned. All right. Here I have some switches I'll be talking about. Basically, there is a ton of different options and different type of switches that could be used in a pedal, and some of them you've probably come across so far. For example, one of the things I'm not going to talk about is something like this. This is a momentary switch. So what does this mean is just, it doesn't latch. So when you press it, it shorts. When you depress it, it is disconnected. This is useful when, you want to have something like a Boss pedal style, buffered switching, electrical switching, or if you're using a relay, for example, So I'm not going to talk about it. Let me just move it away. So I'll start with the simplest switch. Okay, this is the simplest relevant switch for today. This is single pole double throw. Okay. So what does that single pole double throw mean? Let me show you that real quick. So see how this works. So this is schematic of single pole double throw switch. Here we have single pole and double throw, so that just means that we have one kind of a fixed point, and we have two positions, two things that we want to connect. I mean, if in one position this is connected, in the other position this here is connected. So if I look at these, this switch, what you would, for example, could use this for is when you flip between two different clipping options. I had that in one of my previous videos where, in this position, these two are connected. In the other position, these two. So let me show you that. And it's a good idea if you're ever in doubt, just roll out your digital multimeter and double check. When in doubt, check. So here, as I said, hope you can see this. So yeah, and if I can just make it a bit tricky. So I don't know if this is visible. So, these two are, as you can see, connected. And if I touch these two, they're not. They're disconnected. So I'm going to flip the switch here, and now those two are connected, these two are not. Anyway, just a short demonstration, but if you're ever in doubt, take a digital multimeter and try it out, just to save on the safe side. So let me demonstrate this. This should be fairly simple, to demonstrate how this works. And I know, I apologize, maybe this is too simple for you, but it is kind of I find it most of the time useful to go back to the beginning and make sure that, we understand just those simple bits. We try to, sometimes I have a feeling that, and certainly that's true for myself, I get a bit I overcomplicate things, so sometimes it's good to go back to basics and understand what's going on. So I'm just going to put two, so keep my resistors like this, just so I know where they are. Just gonna quickly, so I'm just going to go and, what's this? This is gonna put here. I'm gonna wire up these two LEDs. Bear with me for a second. So positive side anode, I'll connect to 9 volts, and I'm going to keep them disconnected, right? So let's see if I connect this up, lights up. If I connect this here, lights up. Okay. So what I'm going to do is, and this is not unlike how do we wire up pedal in one scheme of one way to wire it up is I'm going to put in this middle pin, I'm going to connect that to the ground. Okay, connect to the ground. Go in there. Connect to the ground. And then I'm going to flip these two LEDs. So, as I said, in this position, this one is disconnected. So I don't expect the green one to light up. And it didn't. And in this position, this one is connected. So as you can see, I hope you can see this, I have the red one connected. So I'm just going to flip the switch. Yeah. Okay, so just to recap, the ground is connected this way and completes the circuit. So LED is turned on, ground, this one is disconnected, so there's no light. I flip the switch, this one gets disconnected, ground this time goes this way and completes the circuit. All right, hopefully that makes sense. All right, so let's move on to something that's slightly more useful for this discussion, because this is super useful. I think these ones are super useful for modding pedals, but let's talk about double pole, double throw. Okay, so here these two switches are pretty much the same, except if you look at here, I have two single pole double throw switches here. This is one, this is the other. And you can see here, it's depicted here, how this is working. And this dotted line here just means that while they're independent switches, you know, they don't interfere with each other, they work together. So if you flip one, you connect both switches. If you flip to the other side, you connect both switches. So this activation is not independent, but switches electrically are independent. It is more useful to show them not like this, because this is a bit of a, this is, you know, truly depicting how the switches work. But you can see here, it's SPDT is exactly the same as this first part of the switch. Second part of the switch is just the same thing with just different pin numbering, right? So one, two, three, 4, 5, 6. But it's the same way if I number them the other way around. 1, 2, 3, 4, 5, 6. So when 1 and 2 connected, 5 and 4 are connected. When 2 and 3 are connected, 5 and 6 are connected. I hope that makes sense. So more commonly, as I said, you'll see them in various schematics like this. Okay, and it's just easier. You see here it says switch to unit A, switch to unit B. It's the same thing. It doesn't really show that they're related. The activation is dependent. They activate at the same time, but it is handier because, you know, it's easier to show on a diagram. So, you know, if I go and, for example, want to show them, I normally show them like this, you know, separately. Doesn't really matter. I'll get to that part. Okay, there are some nuances, but essentially, this is. And did I say that what does DPDT means? Double pole, so you have two poles, double throw. So it's just, you know, we have two switches or two fixed points and two positions that you can flip between. And these are three different double pole, double throw switches. With some nuances, they really work the same. You know, I have this one toggles latches. You see, it stays down and then goes to different position when I depress it again. This one is a toggle, goes up left or right. Whoops, they lose it. And this is a stomp switch. You know, you can see it latches in two different positions. Essentially, they work the same, and this stomp switch is just more convenient, you know, as your on-off switch for the pedal, because, you know, you want to use your foot to snap on it, where toggle switch would be very inconvenient, you know, if you want to bend over and bend and during playing, it's very inconvenient. But again, this is useful for modding your pedal. But essentially, when you think about it, they work exactly the same. How do you wire them up, essentially? So let me demonstrate this with double pole, double throw. I'll do exactly, well, very similar thing here. I'm just gonna move this out of the way. Let me do this. I have 2 more LEDs. I'm just gonna put them here. And I'll put this one here. Doesn't really matter for this demonstration, but I want to show you that they are actually working at the same time. We need these current limiting resistors. Plug them in here. Be real quick. As long as they don't mess up something. But this is breadboarded, so it doesn't really matter. I need to wire up, just positive side I need to wire up. Okay, there it is. So this goes to ground again. And I'm just going to connect here. Oh, it's on already. I'm just going to disconnect it real quick. Can I get in there? All right, can you see this? Yeah, it's a bit difficult to see possibly. Okay. Works the same. So let me try to find a few more of these so I can wire up the other side. And this is just to demonstrate that, as you can see, that I can use either of the sides for this, and if I can only get this. Jeez, this is a bit tough getting everything in. Okay, this needs to go to the correct place because it's kind of a fixed point, so it has to go to ground. These two I can swap around. Oh, jeez, this is tough. God, I hate all these wires. Okay, you can see there it's working, and I flip them, and they flip together. Whee! This is great fun. And you know, they're independent. I can just, if I disconnect this one, you see, only the top part is working. And if I connect it back and disconnect this one, only the bottom part is working. Okay, let's disconnect this. Hopefully all of this makes sense, and apologize for this, you know, this was too easy maybe for you, and I think it's important to get to some baseline understanding, but it will get a bit more interesting, I promise. With all this out of the way, it's easy to see that we can have any number of these switches, you know, why stop at 2, you know? So that's why we have this 3-pole double throw. Essentially, again, 3 poles and double throw, 3 switches. And you don't need to stop at that. You can have 4-pole double throw, for example. That's becoming more and more popular. Or you can have something crazy. What do you think? What would be 4-pole triple throw be? Well, as it happens, I have it here. You know, This is what you call it? The brain stopped. This rotary switch. You can see there are 4 poles here, and they have 3 positions each. So 4-pole triple throw, 3 positions. This is 1, 2, 3, and 12 connections. This is a real pain to wire up, but it is possible. It's only what is physically, there are physical constraints what you can do. Okay. For breadboarding, you can use toggle switch, which is probably the easiest way to do for breadboarding, because who cares if you don't have the LED, for example. It's easy to see which one is turned on or off. I use this push button. Well, I just had a few, and this one is really handy because I just don't need to solder anything. It's a bit of it's not great for fitting into this breadboard. I didn't look at the spacing of the pins when I was getting it, but what I did was I used this scrap of a strip board and added header pins. So when I plug it in, it's really handy. So I can just plug things in. It works the same way. So I'm just gonna unplug this. Just quick demonstration. This video it's getting bigger, longer and longer, but just so you see, I'm not talking rubbish. I need wires. Okay. So it's the same thing, pole that will go to ground on both sides. I'll make them both white. And then throws. One goes here. One goes there. And one goes here. And I need to plug in power. And you can see already going. Oh, let me not break this. Oh no. And I just flip the switch. That's really it. I can rewire this too, for example, if I want to. Just a little bit of demonstration. This would make things real weird. I could play with this all day. Anyway. I think this is great, but just make sure that this is a latching type, because you don't want this to be momentary switch, and then because it only works until you hold it there in this position, and then how can you play with one hand? Apparently Steve Vai injured himself, so he had his arm in sling, and in his latest album he played the whole song with one hand. Yeah, I'm no Steve Vai. Let's move on. So let's talk about what does true bypass mean. And